Okay. The first step is write it in single rational expression. If you notice, the left-hand side is a single rational expression, but the right-hand side is not 0. So we need to make the right-hand side not equal to 0. So we need to do transposition. We'll have 2 over 3x minus 6 minus 1 greater than 0. Now, how to do it in single rational expression. You need to multiply all by the LCD. And remember, the LCD is 3x minus 6. So you multiply it here, you multiply it in the next one, and also in the last one. If I multiply it by 0, that will still be 0. So here's my technique. My technique is, let me just change the color here. I'll only extend this fraction bar and multiply the LCD by that number. So it becomes 2 minus 1, quantity 3x minus 6, all over 3x minus 6, greater than 0. It will give you the same answer. So we will have 2 minus 3x, distribute that one, plus 18 over 3x minus 6, greater than 0. We transfer to this side. We have 2 plus 18, that will become negative 3x plus 20 over 3x minus 6, greater than 0. This will now be our starting expression. If you got it right, then you'll get it right till the end. But if you didn't get this step 1 right, it will make till the end erroneous. So let's start with step number 2. Numerator, 3x plus 20 is equal to 0. We do transposition. That's negative 3x equals negative 20. Divide all by negative 3. X is equal to 20 over 3. I told you a while ago the technique number 2. If it's greater than, this is false. Not yet. It's not applicable to this one. Redo eraser. Because we need to substitute it to the original. Again, substitute this to the original equation. So we will now have, to the original one, 2 over 3 times 20 over 3 minus 6. This is 20 minus 6 is 14. 2 over 14, that is 1 over 7, greater than 1. It's still false. For the denominator, we have 3x minus 6 equals 0. We do transposition. 3x equals 6. Divide all by 3. So x equals 2. And remember, for the denominator, it's always false. So we plot now our number line. Let's plot. We have 2 and 20 over 3. 2 goes first because 20 over 3 is equivalent to 6 and 2/3. Circle, circle. Since both are false, then they remain open. And you see we have 4 intervals. This is the first interval, the second interval, and the last interval. So we write our test values. For the first interval, less than 2, you could have 0. Again, substitute it to the original. inequality, not to the new one. So for 0, that's 2 over 3 times 0 minus 6. That will be 2 over negative 6. That is negative 1/3 greater than 1. And that is false. Second, between 2 and 6 and 2/3, we can have 3. So 2 over 3 times 3 minus 6. That is 2 over 9 minus 6. That's 2/3 greater than 1. And there's a chat here. Okay. So we have, this one is still false. Let's go to the third one. Let us see if it's true or not. Greater than 6 and 2/3, we write 7. 2 over 3 times 7 minus 6 greater than 1. It is 2 over 21 minus 6. That is 2 over 15, right? Am I correct? Yes. Is greater than 1. Is this true or false? It is still false. Is this all correct? Let us check again. For 0, let me double check first. 2, 6, 2. The other one is positive 20 over 3. Before 2 is false. 0. 3 times 0, 2, negative. That's wrong. The second one, if I'll place 10, it's the same. So it's all false. What will happen if everything's false? Then there's no solution. If you say no solution, it means that no value will ever make it true. So any questions? We stop the recording.